Hello everyone, welcome to the YouTube channel of Tribonet. My name is Manoj. Today, in this video, let us learn about the superlubricity in bearing systems. In 2015, researchers first saw superlubricity at the macro scale experimentally. The experiment involved a graphene-coated surface sliding against diamond-like carbon-coated surfaces under dry conditions. This interaction triggered the formation of the graphene nanoscrolls that were stabilized through introduction of the nanodiamond particles. Using a ball-on disc tribometer operating under nitrogen atmosphere, superlubricity was observed when a ball coated with a hydrogenated DLC was slid against a surface containing two-dimensional molybdenum disulfide and nanodiamonds. This coefficient of friction values were in the range of 0.005, and this achieved due to the stress-induced chemical reactions that converted the nanodiamonds into onion-like carbon structures. Here in this figure, we can see the illustration of the nanoscale lubricity. How do we achieve the superlubricity? Superlubricity is often only observed under the very limited conditions that require ultra-high vacuum or inert environments. In more recent cases, under the ambient environments, water-based lubricants were used on very smooth ceramic surfaces to produce the superlubricity under high-speed sliding conditions. In a common application such as the bearings, the solid surfaces often are steels and lubricants are based on mineral oil or some other type of the hydrocarbons. One option is to use the carbon nanotubes under the hydrocarbon lubrication to produce the superlubricity. Carbon nanotubes are cylindrical tubes made up of sp2 hybridized carbon atoms bonded into a network of the hexagonal lattice structure similar to graphene. Depending upon the number of the graphene sheets inside, CNTs may be identified as a single, double and multi-wall CNTs. Here in this figure, we can see the schematic representation or illustration of the carbon nanotubes for superlubricity. What is the mechanism behind this? The mechanism suggests that the CNT coating is sacrificed in situ to form a tribo film that creates the condition in reciprocating sliding tests for superlubricity. Scanning transmission microscopy and elemental mapping conducted using the energy dispersive X-ray spectroscopy data supported this hypothesis by finding a mixture of the carbon and metallic nanoparticles, primarily iron and chromium, in the tribofilm. The oil prevents scuffing failure during the running-in phase, reduces the adhesion between the two contact surfaces and minimizes the wear rate, removes the wear debris from the interface and helps to align the graphene flakes into the tribofilm to being presumably parallel to the metal surface. So in these experiments, which were run under the dry without oil, they noticed that immediate scuffing and coefficient of friction values were 2 orders of the magnitude above the lubricity level. In this video, we understood the superlubricity in the bearing system, what is the superlubricity, how do we achieve the superlubricity in the bearings, and what are the mechanisms of this lubrication to achieve the superlubricity. These are the references for the information provided in this video, and thank you for watching this video. To get more details on the topics related to tribology, follow us on our social media pages on Instagram, Facebook, LinkedIn, and do not forget to subscribe to our YouTube channel Tribonet. Also visit our website on www.tribonet.org.